students, today we're going to learn the polynomials from the second chapter. First of all, let us see what is polynomials in one variables. An algebraic expression of the form p of x is equal to a0 or plus a1x plus a2x squared plus a3x cubed plus so on up to an x power n, where an not equal to 0. This an is not equal to 0 is called a polynomial in variable x of degree n. Here a0, a1, a2, a3 up to an are real numbers, and its power of x is non-negative integers. Example, 3 to the power 3x squared minus 5x plus 2 is a polynomial of degree 2. Why? Because the highest power of x is 2. That is why we call this polynomial is of degree 2. But this is not a polynomial. Why? Let us see in detail. See, for a better understanding, I want to give you some example of polynomial here. Suppose when you write 2x power 4, 3x squared plus 5x plus 9 and so on. Here, x is a variable. And the power of the variable, see, what is the power of the variable here? 4, here 2, here 1, here 0. And the power of variables are all whole numbers. And another word we can also say non-negative integers. When we say non-negative integers, means they are whole numbers. So when we take any algebraic expression in which the variables power are whole number, then we call them as polynomials. And why this is not a polynomial? For example, let's see here, 3 root x plus 2 is not a polynomial, because when you write this in the, that is 3 root x is nothing but x power 1 by 2 plus 2. The power of x here is 1 by 2, which is a fraction, which is not a whole number, so it is not a polynomial. Now, for a better understanding, I will tell you something here. If you write like this, say root a to the power m of order m. When you write in the exponential form, how will you write? A to the power m divided by n. This is called radical form and this is called exponential form. So when you write root x, how will you write? X to the power, here is power is 1, here is 2. So here is 2. Usually we don't write 2 here, but we have to understand there is 2. So when you write the exponential form, you get 1 by 2. So here the power is fraction. Another case is when you write like this. How you going to write in the exponential form? X to the power 2 by 3. So this is called radical form and this is called exponential form. Let us see some more. When we write, say, y squared plus 2 by y plus, say, 4. This is not a polynomial. Why? Because here y squared plus 2, when you bring this y up, the power of y here is 1. So when you bring up, so this will become y to the power minus 1 plus 4. So this is become a negative power, which is not a whole number. Therefore, this is not a polynomial. So you should be very careful of the power of the variables. Now, let us see types of polynomials. So in a polynomial, for example, if we write 2x plus 4, there are two terms. These are called terms. How many terms are there? Two terms. And if I write only say 7x cubed, is having a single term. So let us see types of polynomial based on the terms. The first one, consider the polynomial 2x or 2, 5x cubed or minus 5x squared y and e to the power 4. Do you see that each of these polynomial has only one term? So polynomials having only one term are called monomials. There are examples of monomials, and what is monomial is a polynomial having a single term. The next, see, now observe each of the following polynomial. Now here, p of x having how many terms? 1, 2. Then x plus 1. How many terms? 2 terms. And here also we have 2 terms. X squared minus x, 2 terms. Here y to the power 30 plus 1. Here's the 2 terms. Here also 2 terms. So this type of polynomial are called binomials because they have 2 unlike terms. For example, if I give you this one, for example, say 2x plus x. Of course, here there is 2 terms, but this is not a binomial because they are like terms. You can add. So you will be when you add this one, you will get 3x having a single term. So it becomes a monomial. This is not a binomial. So the term should be unlike terms. So similarly, when you have a polynomial having 3 terms, unlike terms, 3 unlike terms, that polynomial will be called trinomials. Next, degree of polynomial. What is the degree of polynomials? Say, very simple idea. The degree of polynomial is nothing but the highest power of the variables in a polynomial. For example, here, can you see here? This is a polynomial. The highest power of y is 2. Here's 1. Here's 0. So highest power is 2. So the degree of this polynomial will be 2. So let us see what is the definition here. If p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial. For example, 4x plus 2. The power of x here is 1. So the degree of this polynomial is 1. Here, the degree of y is 2, so the degree of this polynomial is 2. Types of polynomial based on degree. Based on degree, the polynomial are divided into different types. For example, a polynomial of degree 0 is called a constant polynomial. A polynomial of degree 0 is called a constant polynomial. For example, you can have, say, 3. There is no variable. If you want to add variable, you can add like this, x, like this. X to power 0 is nothing but 1. So you can write 3 into 1, that is 3. So this type of polynomial is called constant polynomials because the degree is 0. A polynomial p of x equal to ax plus p, where the power of x is 1, then if the degree of this polynomial is 1, this type of polynomial is called linear polynomial. It's called linear polynomial. Next, a polynomial p of x equal to a x squared plus bx plus c. Here the degree of polynomial is 2, so the polynomial is called quadratic polynomials. And likewise, if the degree is 3, the polynomial is called cubic polynomial. And if the degree is 4, it is called biquadratic polynomials. So I hope you understand what is linear polynomial, constant polynomials, quadratic polynomials, cubic polynomials, biquadratic polynomials. Let's see next. This is some of the questions I have taken out from your exercise 2.1. The first question, which of the following expressions are polynomial in one variable and which are not? State reason for your answer. Here, the first question here, 4x squared minus 3x plus 7. Here, what is the variable here? X. There is a single variable, say x. Now this is of course, this is a polynomial in x because the degree of the power or the power of x are all whole numbers. Here, what is the power of x here? 2, here 1, here 0. That means the power of the variables are whole numbers. So this is the polynomial in one variable because the power of the variables are whole numbers. Roman number 2. Let's say Roman number 2. Y squared plus root 2. So when you see, you can express this one in the exponential form also. Y squared plus 2 to the power 1 by 2. But you have to see the power of the variables only because by the definition of polynomial, you have to see the variables of only. Of course, 2 is not a variable, so you need not see the power of 2. We don't need to see the power of the constant. So we have to see the power of the variable. What is the power of variable y? 2, which is the whole numbers. So this is also a polynomial in one variable. It is a polynomials in one variable because the power of y is 2, which is a whole number. Now let's see the Roman number 3 and 4. Here Roman number 3, 3 root t plus t root 2. When you write this radical form in the exponential form, you will get 3 t to the power 1 by 2 plus t root 2. We don't need to expand, or we don't need to express this root 2 into exponential form. So the variable t has a power 1 by 2, which is a fraction and which is not a whole number. Therefore, it is not polynomial because the power of p, the power of t is half, which is not a whole number. So this is how you going to answer like this. Here 3 root t plus t root 2 is, when you express in the exponential form, 3 t to the power half plus t root 2. Here the power of t is half, which is not a whole number. Therefore, this is not a polynomial in one variables. But of course, it's not a polynomial finish. In the same case, this number 4 y plus 2 y to the power minus 1. When you bring this 1 upside, y upside, you get a power of minus 1. So this is not a polynomial because the power of y is minus 1, which is not a whole number. Likewise, this is see the last question, the Roman number 5. X to the power 10 plus y cubed plus t to the power 50. Here there are 3 variables, x, y, t. This is of course a polynomial, but it's not a polynomial in one variable. It is a polynomial in 3 variables. So you have to write, this is not a polynomial in one variable because there are 3 variables, x, y, and t. Okay, let's see the next questions. Write the coefficient of x squared in each of the following. So when we say coefficient, we have done in class 6, 7, 8 or so, the coefficient. So let's see, I'll take the first one. 2 plus x squared plus x. So our aim is to find out the coefficient of x squared. So you have to see the term containing x squared only. The term containing x squared is this. This is a term containing x squared. So when you remove x squared, what we have? Plus 1. Here, 1. That is nothing but the coefficient of x squared. So coefficient of x squared equal to 1. What about here? In row number 2, the term containing x squared is minus x squared. So the coefficient of x squared will be minus 1. So what is the coefficient of x squared in this polynomial? It will be minus 1. You have to be very careful of the sign. What about here? The term containing x squared is pi by 2x squared. So when you remove this x squared, the remaining are the coefficient of x squared. So the coefficient of x squared will be pi by 2. See the row number 4. There is no term containing x squared. There is no term containing x squared. So the coefficient of x squared will be 0. Because there is no term containing x squared, so the coefficient of x squared in this polynomial will be 0. Let's see the next question. Here you are going to give one example of a binomial of degree 35 and monomial of degree 100. You can have infinite numbers of polynomial of this type. So the answer what I have given you may not be same as you think. So you may have different examples. Let's say binomial of degree 35. So when we say binomial, we'll have two terms. Don't forget that binomial have two terms. So you can write any two terms here, say x plus 4. Of course. Then the question is degree 35. Just put the power of a variable at 35. Finish. You can have different examples. Okay. Next question is monomial of degree hundreds. So when we say monomial, we'll have a single term. You can write any variable, say p, t, q, b, and so on. So let's write p. Then put the variable. We have put the variable p and put the power as hundreds. And you can add any coefficient if you want. You can add 2, you can add minus 2, you can add anything. This is one of the examples of a monomial having power hundreds. So at home what you're going to do is, with this same question, try to write more examples of these types. Let's see the next question. Here, write the degree of each of the following polynomials. So when we say degree, let us recall what we have learned before. Degree is nothing but the highest power of the variable in a polynomial. So let's take the first question here. 5x cubed plus 4x squared plus 7x. So what is the variable here? The variable here is x. And the power of x are 3, 2, 1. And the highest is 3. So degree of 5x cubed plus 4x squared plus 7x is 3. Let's see this one. 4 minus y squared. What is the variable in this case? Y squared, y is a variable. So the power of the variable is 2. So the power or the highest power is 2. So the degree of this polynomial is 2. Here 5t, the variable is t. The power of t is 1. So the degree of this polynomial is 1. What about this? Single number 3. There is no variables. So the power of any variable will be 0. So degree of 3 is 0. Because there is no variable. If you want to put variable, you can put x, y, and so on, and put as the power as 0. Anything to power 0 becomes what? 1. So that is only. So the power of a constant is always, means the degree of any constant number is 0. Okay, let's see the next. Now here, classify the following as linear, quadratic, and cubic. So let's recall what is linear. Linear is a polynomial having a 1 degree. Quadratic, a degree of 2 polynomial having that means the polynomial having a degree 2. A cubic, a polynomial having 3 degree. Here, the highest power is 2, the degree is 2, therefore it is a quadratic. The first one, x squared plus x, is what? Quadratic polynomials. Likewise, I want you to do all the remaining questions. There's Roman number 2, 3, 4, 5, 6, 7. It's very, very easy. What you're going to do is you have to find out the degree of the polynomial, then you have to write the types of the polynomials. Don't forget to do your homework. Thank you very much. I hope you understand what is polynomials, types of polynomials, degree of polynomials, coefficients of the variables in this chapter. I hope you'll do the homework. Thank you.